All right. Hello, everybody. Welcome to a rare Richard solo stream. This is the MakeCode Arcade Advanced stream, and I am at Richard on the MakeCode forum. So today we're going to be doing something a little bit different because it is a solo Richard stream. Thomas and Joey, who are usually here on Mondays, couldn't make it for various reasons. But what we're going to be doing today is I have this side project that I've been working on. It's a MakeCode project. It's a music tracker. We kind of started it a little bit the other day in on stream, but I did a lot more work on it afterwards. And I thought it would be fun to work on this today since it's just me. But I have not actually set up my environment, my dev environment on this computer. This is the computer that we normally do streams on. So I figured today there'll be some coding for sure, but we're going to be looking at this project that I have and also how to set up my dev environment for this MakeCode project that we are going to be coding. So a little bit of background. When I do development on Windows, I typically do it inside of Windows Subsystem for Linux, which basically lets you run Linux. In this case, I'm running Ubuntu on top of Windows. And I like doing that just because I'm used to programming in a Linux, Unix types of environment, and that's what we're going to be doing today. So the one thing that I have done in advance is I've already got WSL installed on my machine. Okay, so here we go. This is Ubuntu, which I'm running right now, which is running inside of Windows. So I can, run Ubuntu-like commands. And the other thing that I've done is I've installed NVM. So one thing to know about MakeCode stuff is that we typically write our code in JavaScript. And when you're doing stuff on the command line with JavaScript, you need to have Node installed, Node.js. And the way to install Node.js, the modern way, is to use MVM or NVM for Windows. So I have those already installed. And that means that I can say like MVM use v22. And now I'm using Node v22. So, whoops, yeah. So just a basic idea of what's going into the setup here. The other thing to know is that I already have Git installed because, Git just comes with Ubuntu. So, all right. So we're going to go ahead and clone this repo to start. Oh, one other thing to note. Typically, when you're coding MakeCode projects in the command line, you should use VS Code and the MakeCode extension. Now, I don't use the MakeCode extension, and that's because I'm just used to using our MakeCode CLI. So I'm going to be showing you how to use the MakeCode CLI today, not the extension, and do with what you will. But that's what I'm going to be doing. So first things first, we're going to clone this repo. So I'm going to go ahead and clone this right here. This is Rick Knowles' PXT tracker if you want to follow along on this project that I'm doing. So, we're going to go ahead and type git clone and paste in our URL. That's going to go ahead and clone it into this PXT tracker directory. So let's head into there. And we're going to run code dot to open up VS Code. And yeah, just going to allow that. All right. Cool. Okay. So now we got VS Code open, and we have this project. So how do we run this project from the command line? Let me also just zoom in a bunch so you can hopefully see what I'm doing a little bit better. So typically when you've seen us do stuff that's kind of like in VS Code before, like I said, we use the extension, but we're not going to be doing that today. So instead, what we're going to be using is the MakeCode CLI. So the MakeCode CLI is an NPM package. And it's really nifty for doing this command line stuff. This is really only for like power users, but if you're interested or you have some experience doing stuff with the command line, then you might find it pretty useful. So I'm going to go ahead and install that package right now. So I'm going to do npm install -g. -g, that makes it global, and the package is just called MakeCode. So I'm going to go ahead and do that. It's going to install that. Now, if you're doing npm install -g, you may have to enter your password depending on your operating system, or do an admin prompt if you're on Windows or something like that. I've already done sudo, so that's why I didn't have to do it here. But all right, so we should now be able to run MakeCode, and this is going to go ahead and download the MakeCode editor for Arcade. All right, so we went ahead and did that in the background. It built it, says build okay. Now I want this to actually, I want to be able to like actually see and play with this thing that we're doing. So I'm going to go ahead and do MakeCode serve. And this is going to start a server that will, I can open in my browser, and that will let me run my code. Oh, right, I forgot there's a bug right now in Arcade. Ooh, okay. Ooh, we might be doing some even more command line stuff while I like fix this bug. All right, cool, okay. We're gonna fix this bug. All right, so what is this bug? Right now, this is stuck in an infinite reload loop while I'm trying to load the simulator. Now, to fix this, what I'm going to do is I'm actually going to clone the Microsoft CLI. I'm sorry, the MakeCode CLI, which is inside of Microsoft/txt_mkc right here. I'm going to go ahead and clone this repo. By the way, you won't have to do this fix because, presumably I'm going to fix this. All right, I need to set up my usual shortcuts in the terminal. So that will take me 1 second. But you know what? I'll do it later. It's not really important for now. Let's see. No, wait, I don't know how to do anything if I don't do it. So we're going to go ahead and do open JSON file. Yep, this is fine. And then in here, we have some, this is where you can customize the Windows terminal. So I'm going to put in the customizations that I always put in the Windows terminal while oh, whoops. Okay, no. Sorry, I'm opening my laptop so I can copy this from my other screen. So this is going to take me just a second. Hello, Sarah.
Hello. Sorry, I'm late. I noticed your message pretty late, but I'm here.
Yeah. All right, we're doing something weird today, Sarah. So I'm going to be showing off some of my actual dev workflow. Ooh.
Oh, okay.
Yeah.
Wow, I guess it's time for me to take notes too, because I could probably be more efficient. So
I don't think it's going to actually, help you that much, but we can go ahead. The first thing I'm doing is I've set up the dev environment on this new computer. But there's one thing that I always do, which is inside of the Windows terminal settings, I have a bunch of shortcuts that I have to register because I cannot use the terminal unless I have them registered. So this will take one second while I go ahead and open it on my other computer so that I can just copy them.
I don't know if I've ever registered a shortcut.
Yeah, you don't. Typically, people, I think, just use the built-in ones, but I have some that I prefer, and so it's like the first thing I do on every computer when I'm setting up the Windows stuff is to.
And is this for like WSL, like Ubuntu dev work, or is this like command prompts, getting stuff started shortcuts?
These are shortcuts for splitting. Oh my God. Sorry, I'm struggling with Windows right now.
Good luck.
All right. So these are shortcuts that I use for splitting panes. So if you've ever seen me use the terminal when I'm like sharing my screen or something, I split panes all the time. But I do not like the normal shortcuts for splitting panes because they don't do what I want.
Right, like the Windows arrow keys ones.
Is that what it is?
Is it not? Maybe not. Maybe.
No, Windows arrow keys is like that's for like moving windows around, right?
Okay, splitting panes is something different than that.
Yes, it is.
All right. I think I have seen this from you though, where you have like 4 terminals open at once on one.
Yep, screen. That's what we're talking about.
Okay.
Oh my god. I can't remember what the magic thing is for rescuing windows that have gone off screen in Windows.
So like,
All right, I got it.
if you do
Okay.
Windows arrow keys with something else, it does show you all your open windows. But I don't know if that's what you're meaning.
Yeah. Okay. All right, so we're going to go ahead and register these things. By the way, you obviously do not need to use these. This is just what I use. So I use, you define the command like this. I'm going to go ahead and do action. This is going to be split pane. Oops. Then we do split colon auto, like my cat. Split mode duplicate. And then ID user.split pane dot, and then there's just a number and stuff after this, which I'm just going to copy, even though I don't know what it means. A67517878. Cool. All right. All right. So we're going to go ahead and copy and paste this a couple times. Actually, don't know why this is. Oh, I put too many names. There we go.
I feel like that is something I do a lot that is so hard to catch. Like, how many M's are in here? I don't I don't know.
All right, we're going to call this user.splitplane.auto. We're going to call this one user.splitplane.down. This one is going to be down. And then we need right. So we're going to copy this again. Right. Right. Okay. So we set up these actions. We now need to bind these to shortcuts. So we're going to go down to key bindings, and the bindings that I used for these are so for the ID, we're going to put in that action we just created. So let's do user.splitplane.down. And then for the keys, we're going to be doing Alt-Shift-H. And then for the next one, we are going to paste this. This is going to be right, and this is going to be Alt-Shift-V. There we go. And then the last one we need is to close a pane. So for this one, we're going to paste. This is going to be user.closePane. And this is going to be Alt-Shift-W. And we need to create an action for this close pane one also. So put it in here, and this is going to be command. Instead of putting in this object, we're just going to put in close pane, and then this is going to be user.closePane. Okay, all right. This should do it. Control S, head on over here, save, go, hit over here, Alt-Shift-V, there we go. All right, all is right with the world now. All right, so this lets me create multiple terminals. The default commands for splitting panes, it doesn't copy your profile, so it'll just always open in command prompt. When you do these ones that I just made, it duplicates whatever you were doing. So if you're in command prompt, it'll make another command prompt. If you're in Ubuntu, it'll make another Ubuntu. And it has the keyboard shortcuts I like. So that's why I do this. All right. Anyway. So we're going to go ahead and clone this pxt mkc repo because we're going to be fixing the bug in this one. So clone this, cd work, git clone this. There we go. cd pxt mkc. We're going to go ahead and do npm install -- workspaces. There we go. And we're going to open this up. All right. Now inside here,
what does that -- workspaces flag do?
This is so this is the one repo we have in the pxt collection
Cinematic
of repos
universe.
that is a mono repo. So we have multiple packages inside here. There are 3 packages. There's MakeCode browser, MakeCode core, and MakeCode node. So MakeCode node is the one that gets published on npm as MakeCode, but all 3 of these exist in this thing. So when you do npm install -- workspaces, we have a package.json in the root here that has workspaces set up. Let's see. Gimoari says, I think the stream audio is getting cut off or something because I can't hear what you are saying. Interesting, because I can see the audio coming through in StreamYard. Sarah, would you mind loading up the Twitch stream and seeing if you can hear me talk?
Sure. Yeah, I've been able to hear you fine on stream.
Yeah. All right. We're going. We have these workspaces defined. So when you run -- workspaces, it will basically run whatever command you gave it inside each of the workspaces. So it's going to run it inside of MakeCode core, MakeCode browser, and MakeCode node, which is what we wanted. So that's why I did that. And we can also go ahead and build all of them. So we're going to do npm run build -- workspaces. And this will run npm run build in all 3 of those directories. So there we go. Okay. We're going to be fixing this inside of MakeCode core, and I'm not going to go into how this repo is structured. I already know what the problem is. So we're going to go into SimLoader. We're going to go into, let's see, loader.ts. And the bug that's here is that I made a change a while ago, which is that I converted this text thing right here to, I wonder why it's not giving me any IntelliSense right now. I guess the TypeScript language service is not happy for some reason.
So I watched a little bit of the stream. It seemed like when I first joined the stream, your audio was very low, and then it picked up again. But I haven't noticed it since I joined after.
Okay.
It seemed consistent. But I'd like to stop watching this in dual time because I'm trying to.
All right, that's fine.
What time you're talking versus future you?
Well, I moved my mic closer, so hopefully that will, rectify it if it is a problem. All right. So inside of this fetch source code, I changed it so that this text parameter right here is actually a promise instead of a string. So we can go ahead and look at that function, see that. So we do this fetch source code, then we do .then, and then we do text equals resp.text. Now this returns a promise, not a string. So we're actually going to turn this into an async function like this, and we are just going to do text await resp.text. There we go. I wonder why that made it angry. I think we can just fix this by doing promise fetch result. There we go. That fixes that. Okay, now we're going to go ahead and do npm run build -- workspaces. That's going to build everything. We're going to head back over here, and instead of running MakeCode serve like we did before, we're going to test our things by running the local one instead. So to do that, I'm going to go ahead and do node /pxt-mkc /packages /MakeCode node/built/cli.js serve. All right, I'm going to do the same thing. It's running our simulator walked up here, but oh, look, now it works. So we now have the thing actually working. So like I said, you won't have to do this when you're actually, editing stuff on the command line. I will fix this bug. But in the meantime, we've fixed this for now. Okay. So what is a music tracker? What are we working on here? So, Sarah, have I given you the music tracker spiel before?
If you have, I've completely forgotten it.
Okay. So the idea of a music tracker is it's kind of like making music using an Excel spreadsheet. As weird as that sounds. The idea is that everything travels downwards, okay? You have tracks. These tracks have notes, and then they have values that you can edit for the note, right? So right here, this first column that we are on is called the note. You can see it right there. If I switch over to here, we have the velocity, which is the volume of the note played. Next column is the instrument, which I put in the junk thing here, xylophone. It will not actually play a xylophone sound. Then we have FX type. We're not going to get into what FX do, but basically these do, well, the basic idea is that there are a bunch of different ones of these, and they do stuff like making the notes trigger more than once, making the note trigger later, skipping a step, stuff like that. It's all stuff for just like messing with your song. And this is the FX value, which depends on whatever FX you have selected. Okay. So the idea of a tracker is that you just enter in your notes like this. When you press play, each of these is a 16th note, basically, and the playhead will just go down here and play them all in order. And that's how you make a song. So we have 4 tracks, and you can switch between them right now. Now, I started out doing this as a clone of what was the classic like tracker. So when people think of trackers, they typically think of Amiga Pro Tracker, which was like the one that kind of popularized this concept way, way, way in the past. Okay. So I was making this based off of the Amiga Pro Tracker, which is, you can see right here, the basic idea. So here are the notes. Here are velocity, the effect values, all of that good stuff, just like that, what I had. Now, I've been playing around with a lot of trackers recently, and I found one that I like much, much more, which is called Little Sound DJ.
I like the name.
Yeah. So Little Sound DJ is a tracker for the Game Boy.
Nice.
So let's go ahead and open this image in a new tab. And it works very similarly, except it's a lot better, I think. So basically, the way it works in Little Sound DJ is you have tracks, just like we were talking before. And, you have this grid that you're entering notes in before. But your song is kind of divided into different parts. Now, this isn't an idea that is unique to Little Sound DJ. I have used many sequencers in the past that have the same kind of like structure going on. But the basic idea is you have a song. That's the S over here. The song is divided into tracks. Each track has chains. That's what the C is here. Each chain has a pattern, which is what's here. And then you have instruments, and this is tables, which we're not going to get into. But the basic idea is a song is an ordering of chains, a chain is an ordering of patterns, and a pattern is a collection of notes. Okay. So what you would end up doing is, let's head back over to our code. The idea is you would have a song has tracks. Sorry, yeah, a song has 8 tracks. Each one has a collection of chains that it's playing. A chain is a collection of patterns. And a pattern is a 16-step sequence of notes. All right. So let's say that our pattern looks something like this. A, B, C, B, A, B, G, D, E, F, D. I don't know, whatever. Okay, so you have a bunch of notes. All right. And we're going to call this pattern 1. And now let's say we have pattern 2. This is going to be no notes. And then we have pattern 3 is going to be A blank, 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 B blank, 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 blank. Okay, all right. So we have 3 patterns. They're like this. Now, obviously, when you're doing patterns in Little Sound DJ or trackers, these have not just note values. They're also like, you know, velocity and the effects and all of that stuff. But we're just simplifying this for now. So we have 3 patterns. They're O1, O2, and O3. Now, I want to make a chain. So we're going to say our chain 1 is going to be a collection of patterns. So I'm going to say this chain is going to play pattern 1, pattern 1, pattern 2, pattern 1, pattern 2, pattern 1, pattern 2, pattern 3. All right. So I have now made a chain that's going to do this ABC, whatever, 2 times. It's going to do silence 1 time. It's going to do the first one again, silence again, first one again, silence again, and then the third one. Does that make sense? So whereas this one is a chain of notes, this one is a chain of patterns. All right.
Yeah, that makes sense.
And now in the song, I have my tracks, right? So let's say on track 1, I want to play pattern 1. Right? But if I had a second pattern defined, so let's say we have like, you know, a second chain defined. So I have like O2, and this one's just going to play 3 a bunch of times. Then I could say for track 1, I want to do O1, then O3, then O1, then O3, then O1, then O1. That's the end of my song. All right. So you make a song out of chains, you make a chain out of patterns, and you can have as many as you want, and you can assign them to the different tracks. So why is this cool? I guess it's like a bunch of indirection, I guess. The reason this is cool is because songs are often divided into little chunks, right? Like you have a chorus, you have a bridge, you have the intro, the build, stuff like that. So you can kind of imagine that you might have, okay, this pattern is going to be the first part of my chorus. This pattern is going to be the second part of my chorus. So I'll make this chain, which is pattern 1, pattern 2. So that makes my full chorus. And now when I'm in my song, I can say, okay, I'm going to do my intro chain, chorus chain, bridge chain, chorus chain, bridge chain, outro chain, right? So I'm reusing all of this stuff really easily, and you can kind of tweak all of them to make it different as you go through. But it's a nice way to kind of like structure your music, right? And it lets you reuse things, you know, however you want, which is nice. All right. So let's go back to our Little Sound DJ thing now that we kind of have an idea of what we're doing. So what makes Little Sound DJ really cool is it's really simple, which does not seem like the case, but it is once you kind of know how to get around. The main thing is Little Sound DJ is made to be used on a Game Boy. So it has the same number of buttons that we have in Arcade, plus 1. They actually have 1 more button because the Game Boy has a start and a select button, but close enough. And to navigate through all of these different screens, we have this little menu down here. So this one that's highlighted is where you currently are, right? So you can see phrase 00. I was calling it pattern. They call it phrase, but you get the idea. So phrase is what we currently have. If I were to hold the select button and press left, then I would go to whatever chain I was just editing. If I press left again, I'll go to whatever song I was just editing. So you like have this little menu that always tells you where you are, and you can press select and left and right to go through it. And there are also screens above and below. I'm not going to go into what all of those are, but you get the idea. So you have this little menu that's constantly telling you where you are and what you're moving between. And it ends up being really nice and fluid once you kind of wrap your head around it. All right. So I want to make my tracker a little bit more like this one. And so what we're going to be doing today is we're going to be kind of restructuring the code to make that be easier to do. And then we're also eventually going to be redoing this UI to be closer to this as well. As much as I like this little skeuomorphic track thing I have going on with the nice little animating things here, having all of the tracks at once is kind of not really good for this structure, right? Because the idea is, you want to be editing all of these things separate from one another. And the other thing that's not great is the way this is right now, I have 1, 2, 3, 4, 5, 6, 7, 8 steps that can be shown on screen at one time. Whereas I need to have 16 shown because that is kind of like the working unit in Little Sound DJ. And so I'm going to have to redo this UI if I want to have 16 of these guys visible. And that means we're also going to have to use a smaller font than what I'm using here. So this font is I think 8 pixels high. So our screen is 120 pixels high. So if I were to divide 120 by 16, let's see what that is. 120 divided by 16 is 7.5. So the tallest I can make characters be is 7 pixels. And then we want 1 pixel of spacing. So the tallest we could be is 6 pixels, basically.
That seems small.
Yeah, I mean, so we have a 5-pixel font in Arcade.
Oh.
And let's see, is this a 6-pixel font or a 5-pixel font? Let's see. Where's something that'll make it easy to count? 1, 2, 3, 4, 5, 6. Okay, so I have a 6-pixel font to find here, but we're going to need a 5-pixel font.
That's not bad.
Yeah, I want to do a 5-pixel font though, not a 6-pixel one. Just because it's going to be a little bit easier, I think, for 6 pixels will let us fill the entire thing up, but we won't have any room for anything else. So I think 5 is just going to give us a nice little bit of wiggle room, which will be nice.
Makes sense.
All right. So we'll make a font for this later, but for now we're just going to use the built-in font. And I'm going to go ahead and let's see. Let's split this pane. Alt-Shift-H. CD work PXT tracker. Open this back up. All right. We're going to go ahead and mess with our UI to kind of, well, first we're going to mess with our types. So the way that I have this going right now is you have a song. A song has tracks. Each track has a sequence, which is just a bunch of numbers in a row. And then and that's how it is right now. So we only have one layer as opposed to the 3 layers we were talking about before. So we're going to mess all this up. I'm going to, first though, you might notice I have a bunch of errors right here. And these are for all of the things that are not coming from my project. So to fix that, we need to use the MakeCode CLI to install our dependencies. So I'm just going to do MakeCode install right here. And there you go. That just installed all my dependencies. Give it a second to figure it out. All right, come on now. There you go. Figured it out. So now I have all of my dependencies installed, and so you can see all those errors went away. So if you open up a project, you get a bunch of errors, try running MakeCode install, make sure you have all of your dependencies. Your dependencies, by the way, they get installed inside of this PXT modules folder, which you should never edit anything in here. This is just for, making all the typings work. All right. So we're going to go ahead and just define some new types. I'm going to go ahead and create a new file. We're not going to blow all this stuff up. Don't want it to be inside of PXT modules. We're going to call this types.ts. We're going to do namespace tracker, and then we're going to do export. Here, we'll call this tracker2. Export class song. All right. So a song is going to have a bunch of tracks. Actually, I guess we should start at the bottom and work our way up. So let's go ahead and do export class phrase.
I liked pattern better than phrase.
All right, pattern.
What does a phrase even mean? I guess that's probably more musically inclined though than pattern. But
pattern
I don't know.
is
Pattern
what
makes
I'm more used to using.
Mm.
Because again, for other sequencers. So the first sequencer I ever learned how to use was the good old MPC 1000, which I still have and I still use all the time. This is the first music thing I ever owned.
Whoa.
This guy.
Nice.
My parents bought me a used beat up one in high school, and I have loved it ever since. I have now modded the heck out of it, and I still use it all the time because it's great.
When you mean modded it, as in like you've added things to it?
Yeah.
So like, have you ever had to replace anything to keep it working? Like, did it ever break?
No, it's kind of built like a tank.
Nice.
That being said, NPCs are so popular still, even though they haven't made these in like, I don't know, 20 years. But they're so popular that you can buy tons of parts for them. They're really easy to repair.
Nice.
Yeah. Anyway, though, NPC 1000. Great. But that one has basically the same structure. It has a song, it has sequences, and it has patterns. So sequences are the names for the smallest thing. Patterns are collections of sequences, and songs are a collection of patterns.
Interesting.
Yeah. So.
Yeah, I don't know. Wait, which was the smallest?
The smallest is
sequences
sequence.
smallest?
So
Yeah,
sequence
that makes
is for
sense to me.
sequence of notes. Yeah.
That makes sense to me.
Yeah. All right. We can use our terminology instead. All right. And then we have track. Okay. So the song has tracks. We're going to do this, and we're just going to initialize with 4 tracks, which is kind of arbitrary.
Is there an actual maximum that we have of tracks available to us?
Yeah, so this is kind of arbitrary, but when we're running this on actual hardware, there is going to be a maximum number of channels we can have simultaneously going, like synthesizer channels.
Right.
And so I'm currently implementing a new synthesizer engine to support this project. I'm not showing that off today, but I have it on my work computer. And the idea is that we will probably have 4 channels on hardware, unless, I mean, I'm going to run it and see, how many I can get to work well. But
makes sense.
Yeah. So we're going to go ahead and create 4 tracks. All right. So each track is going to be a collection of patterns, right? And I think what we're actually going to do is inside, we're going to store all of these things in the song. The reason why is because, say I define pattern 1, well, I can use pattern 1 in track 1 or track 2 or track 3, So what we're actually going to be storing inside our track is just a sequence of bytes, right? So for that, we're just going to be using a buffer. So we go ahead and do buffer constructor, this.buff equals control.create buffer 16. And we're going to do the exact same thing for pattern. Pattern is just a collection of sequences, so it's also just going to be a buffer that's 16. Now for sequences, this is going to be more than 16 bytes, right? So we have 16 steps, but for each step, we have a number of things. So we have a note, we have a velocity. So this is a byte, this is a byte. We have an instrument. That's a byte. We have a effect. That's a byte. And then we have an effect value. That's another byte. Now, Little Sound DJ, actually, I don't remember how many effects you can have per step. So that's what this command is right here. So you can see we have a note being played, we have the instrument being set, and then we have the command, which is the effect. Now, on the version of Little Sound DJ I'm playing with, you can have 3 effects for each step. We can kind of decide that later. For now, let's just do 1 because we don't even have 1 working, right? So once we have 1 working, then we can worry about having more.
Just out of curiosity, what are the 3 effects?
So the 3 effects can be a bunch of different things, and I actually have defined what a lot of the effects are going to be. So let's look at my little list of effects I have over here. So normally when you talk about music and you talk about effects, you're like, oh, reverb or delay or something like that. That is not what we're talking about here.
Oh, okay.
Yeah. So effects are things that you can use to kind of just have more control over the notes that are playing, stuff like that. So one example of an effect would be retrigger. So retrigger would make it so that when you have a note listed, you could say, actually, I want you to play this note 3 times in this step. So instead of doing ba, it'll do ba ba ba. It's an idea. So retrigger, its values are internal or interval, or how many ticks per each of those bups and how many times to repeat. Okay, next we have cut note. So say I want to make a note, but I want to play it for shorter than 1 step. So for this one, I would say, okay, play it, but I want you to cut it after 3 ticks. So then it'll only play for 3 ticks instead of the full step. So that's what cut note is. Nudge. So this lets you just make the note play later. So I can say I want this to play, 3 ticks instead of right on the grid. So that lets you do kind of, more natural sounding timing as opposed to just having everything be quantized. So it's just always playing on the beat. Because, humans don't play on the beat. Another one might be to set the tempo. So change the tempo of the song as it's playing. So you want to have a song where the tempo goes up? Sure, that's one. Jump to position. So if you want to make it so that when you get to this step, you go to another step. So say I want my chain to be only, my pattern to be only 3 steps long instead of the full 16. So then I could do note, 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 jump to 0. And so then it would only play 3 notes. It would go bump, 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 bump. Which is cool because then you can do things called like polyrhythms and stuff like that. So you can have like one track that plays 3 notes, one's playing 5 notes, and then these things loop at different paces, right? So it's constantly changing until they get on the same rhythm again, right? It's kind of fun.
So I'm getting slightly confused here. It seems like the effects, like it feels like they happen at different levels. Like some of this affects songs versus some of them affect specific notes / sequences.
Yeah,
they all? But like
this one is global, but the rest of these are all not global.
Gotcha.
So all of these are just on the sequence level.
I see. Okay.
But this one is global. So this one sets the tempo for all tracks, right? This one will just be jumping to the position in one particular track that's playing one particular.
Right. Sequence. Gotcha. That makes sense. Yeah, that's funny though. When you said jump, I'm like, oh, like in machine code when you can jump and then you have a return.
It's exactly what it is.
But this doesn't necessarily mean you have a return, but like once the sequence is done, it'll keep going, right?
Yes.
Like, yeah.
Exactly. So eventually it's going to move on to the next sequence, regardless of what was in here.
Yeah.
Okay. Loop. Loop is for looping. So this is exactly like loops in machine code, like you're familiar with. So the idea is just jump back to this position 3 times and then let it go by. Hi, astronomer. All right, so those are all kind of like the control ones. These are the ones that are just for like controlling how notes play. These next ones are for like controlling the actual sound, right? So this one is set slide. So the idea here is normally when you play a note, it goes like beep, beep, because it just, jumps to the next one. This one will make it so it goes like beep, like it actually slides up to the next note instead of making it two discrete things. That's the idea there. Set volume, pretty self-explanatory. Set pitch bend. This just lets you bend the pitch. So, for example, say I want to increase the pitch, but I want to increase it by less than a note. You can use pitch bend for that. Hi, Robbie Zero. Portamento and glissando. So this is kind of similar to slide, but what portamento does is every time a new note is triggered, when that new note is triggered, it'll move up to it from wherever the previous one was. So if I had a note played, now if I play another note, the oscillator is going to like move up to that note from wherever it was. The reason it's different from slide is because with slide, the idea is that it does not re-trigger. So I'm playing my note, it's just going to change frequency, but it's not going to re-trigger everything. But with portamento, we're getting into the weeds here, but they're slightly different. Glissando is the same as portamento, except that instead of like doing like beep, the idea is that it will only move up at the intervals of keys on a keyboard. All right. So glissando will go like beep, 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 beep. Instead of doing beep, it will go at each discrete note and just hold there for a certain amount of time and then go to the next one. So that's for more of like a piano playing effect, because in pianos, you cannot slide. You do the individual notes.
Oh, well, I don't know. Haven't you ever done the thing where you just go, meow?
That's glissando though, because it's playing each of the individual sounds, just real short.
Yeah, but it doesn't really sound like that.
No. The way that you do portamento is like you're on a guitar and you like hold the string and you like move your finger up, right? Because that's continuous.
Right.
But on a piano, everything is like quantized. There's no way to do a note halfway between two keys. Unless, I don't know, you touch the strings inside, which is frowned upon. Unless you're John Cage. All right. Then we have like vibrato. So this is like pitch modulation. Then we have tremolo, which is volume modulation. And then we have things for changing the actual sound, like changing the envelope parameters, changing the waveform, yada, yada, yada. You get the idea.
But we can only have 3 of these?
Each step.
Is that what you're saying? Oh, okay. Each step can only have 1 of these. Like, it has a choice of 3.
It has a choice of all of these.
Yes, but it can only be 3 per.
Yes, but each step can only have 3 of these simultaneously. Okay. So, but if you need more than 3, I question what you're doing.
Creating chaos.
Yeah. It's like reasonable that you would like to do re-trigger and mess with the attack on the same step or something like that, but like re-trigger and attack and then like setting the pitch bend, all at the same time. Sure, maybe. But and then there's more to it than that. Now, Little Sound DJ does actually have a way to do these things where you could do more than that on each step. And that's by using what's called tables, which I'm not going to get into because I'm still wrapping my head around it really. But the idea behind tables is you have like for each of these steps, you have another 16 grid inside it. It's more complicated than that, but that's the idea. So if you want to like do things within a step, tables are a great way to do it. Anyway, we're like way in the weeds now. Okay. So heading back over to our types. All right, we have a pattern, we have a track, we have a song, we have a sequence. So our sequence is going to be 16 notes long. And this is going to, again, have a buffer. And we want this buffer to be this many bytes times 16. So that's 1, 2, 3, 4, 5 times 16. So I'm literally going to write 5 times 16 instead of just putting 80 because, it's very reasonable that we want to come in and change this later if we add more effects or something like that. All right. Okay. So we have our song, we have our tracks, we have our patterns, we have our sequences. What's left to kind of like make up a project here? Well, we need instruments, right? So I've actually defined instruments over here. They don't actually have anything that you can mess with. But this is what an instrument will actually look like with this tracker. So in here, we have an instrument that has 2 envelopes. It has an amplitude envelope, which is a volume envelope and a pitch envelope. It has pitch bend. It has an amp LFO. It has pitch LFO. It has a waveform. It has whether the gate is on or not. It has the frequency that it's currently playing. Okay. Does that... I've gone over all of these things before. So, Sarah, pop quiz. What's an envelope?
I didn't remember when you told me about the tracker, Richard. I'm not going to remember what an envelope is. I'm sorry.
Yeah, that wasn't fair. I expect whenever I start talking about synth stuff that no one pays attention.
I try to follow along, but after a certain point, I'm like, it all just sounds like buffers
it's complicated.
and bytes, and I'm like, I don't know how these things fit together. I'm like, yeah.
So when we talk about envelopes, imagine that you are playing a piano. Okay, when you make a note, how would you graph the volume over time when you press down a piano key?
Like, I don't know. It's like it kind of also depends on how hard you press it. If you're talking about a real piano, but like hardest when or loudest when you first press, and then tapers off.
Right. So it's a percussive thing. It starts out at the loudest volume and then it goes downwards. Right. Now, how would you describe like a flute? So you're blowing into a flute.
I mean, that just depends on how long you keep going. So it should just be the same time. It should be the same volume the whole time. Theoretically.
It's not, though, because when you start blowing in, you start quieter and then your breath kind of gets up, right? So it goes like up a little bit
that's fair.
And then kind of comes back down and then it's at the sustain, right?
Sure.
So envelopes are a way in synthesizers to kind of replicate these profiles of sound that we have for instruments. All right. And the envelope that's most popular is what's called an ADSR. So we call this attack, decay, sustain, release.
These words sound familiar.
Yeah. So what you can think of is this is our volume over time that we're looking at right now. And when we're on synthesizers, normally when you hold a key, it'll just keep making sound until you take your finger off the key, right? Which is not like a piano. A piano eventually will stop making sound even if you hold your finger down. But
right.
This is for the land of magical electronic instruments, which can just keep making sound all day long. So first step, we have the attack. So this is where we start at 0. This is where the key is pressed, and it's going to go up to the maximum volume. So attack is the amount of time it takes to do that. Decay is the amount of time it takes to drop from that maximum volume to what we call the sustain volume. So if we imagine that flute again, typically you kind of go up to the maximum volume, then it comes down a bit and then it holds at that lower volume. That's the sustain volume. So we go up, we go down, sustain. Then say you lift your finger off the key. There is a little bit of time where it trails off. You can think of it with the piano. You hit it. If you have the sustain pedal down, it's going to keep making noise, right? And so this is what we call the release stage, which is that's going to trail off even after you've lifted your finger. So that's what an envelope is. Now, most people, when they think about envelopes, they think about volume, which is what this one is. But you can also use these for pitch, right? So you'll often hear this with electronic drum sounds. I do not have a sample for you right now, but like toms, like the pitch will go up and then down, stuff like that. Next time we're working on this, hopefully I'll have the synthesizer engine in a state where we can actually play with it a bit, but that's the idea. So these instruments have 2 envelopes. They have an amp envelope and a pitch envelope. Then they have LFOs. These are low frequency oscillators. So imagine an opera singer singing, right?
All right.
they don't just go like ah, they go like oh, where their voice is like going up, down, 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 up, down.
Yeah.
Right.
Yeah.
So that's called vibrato. Sorry,
Yeah.
that's called tremolo. Really, the volume going up and down. And if you do the frequency going up and down, like ooh, that is called vibrato.
Gotcha.
So those two things are accomplished in instruments using what's called low frequency oscillators. So that's just an oscillator, just goes up and down and up and down and up and down. But it does it at like a lower frequency, not loud enough to, well, not fast enough to be like, a tuning fork, like an actual sound. That's the idea. So we combine all of these things together. We can make a lot of interesting instruments, and that's what we're going to be doing. And the idea here is that we're going to hopefully be making a lot of chiptune music with this little tracker thing. Anyway, we're out of time for today. I hope some of this was fun. I think most of it was just me talking, which, that's fine, I guess, every once in a while.
I mean, we started this song stuff. To be fair, it was mostly my fault because I was curious. And
No. That's yeah, you were the audience surrogate. And
oh, can I pick up my cat? Maybe I can show you my cat.
Oh yeah.
Here, Medina. Here you go. Here's a cat.
Let's there we go. Hello, Athena.
No, it's okay. It's okay. It's okay.
No, Athena, no.
Well, you saw a cat for a little bit.
I had a dream last night that Otto was trapped in a cage, and oh my god, it shook me so much when I woke up. I was like, oh, I feel so anyway. All right, that's it for us today. I'm going to keep working on this project. I'll kind of be giving progress updates as I work on it. I'm not going to be doing it all on stream because it's a lot of work. So we're going to be kind of looking at it more when we get on. Assuming that people are back on Wednesday, we're hopefully going to be working on our tunneling game. So look forward to that. It's going to be a much more traditional stream. And brief announcement, we have the mini game jam went up today on the forum. So this one is Wizardry Jam. So you can make a game that has wizards, or, and I made this joke in the post, a game about installing programs on your operating system, because those are called wizards. Yes, it's not funny. So yeah, make some games for that. I am Richard at Richard on the MakeCode Forum.
And I'm Sarah at Sarah on the MakeCode Forum.
And yeah, we'll see you on Wednesday. Bye, everybody.